Okay, welcome back. So what we're going to do now is we're going to look at the quiz. So let me go and share my screen and let's work on the quiz. So the first question is find parametric equations for the circle of a radius 5 with center 2, -1. So the key on this one is I like to think of this as a two-part question. One part is circle of radius 5, and the other part is center 2, -1. So I'm going to work on that and start with the circle of radius 5. And hopefully you remember, if you have a circle, then we want to get x of t. And do you remember what you do if you have a circle of radius 5 or some constant radius? What is x going to be? We'll worry about the center later. Yeah, x is cosine of t, except the radius is 5. We got to bring that in. So how do you make the radius 5? If it was just cosine t, that'd be radius 1. Yeah, it'd be 5 cosine t. So 5 cosine of t.
What if we put theta instead of t?
That's fine.
Okay.
My opinion, it's a lot more typing to put theta.
No,
so
I didn't know how to use the formula function, and then I found this symbol. So.
Oh, okay. Yeah, t is so much easier to type. Don't you agree?
Okay.
But if you want to use theta, that's fine. If you want to use smiley face, that's fine too. If you can stick that icon in. All that matters is there's a letter, and it needs to be the same letter for x and y though. You can't use t for x and then theta for y. That wouldn't be okay. So you have to make sure it's as long as you're consistent, you can use any letter you want. You shouldn't use x or y because those are already used. Okay, and then y of t. Again, right now we're just focusing without the center. We'll deal with the center next. So what is y of t? Right, 5 sine of t. Okay, now that's a circle that is radius 5 centered at the origin. So how do I make it centered at 2, -1? So let's start with the x equals 2. What do I have to do to the x of t? It's very easy.
Add 2 at the end.
Yep, add 2 at the end, so plus 2. And to make it centered with a y as -1, what do I do?
Subtract 1.
-1. That's all there is to it. That's the answer. There's really no work to show on this one.
Larry, I have a question about that.
Yeah, sure.
Isn't it the square root of? Oh, wait a minute. Oh, I went backwards, I think. That's why. All right, never mind.
Yeah, you might
I was thinking I thought it was equals 5. I was thinking of the equation and I went backwards and did square root, but it is 5. Never mind.
Yeah, I mean, if I asked you for the equation of the circle in regular old form, not parametric, then it would be an x. It would be a square root. It would be a square root of x minus 2 quantity squared plus y plus 1 quantity squared equals 5. And there'd be a square root, but that's not what I asked for. I asked for parametric equations.
Yeah, I confused myself. When I saw the radius was 5, like I said, I put it into the equation and then I went backwards from there and did square root, and our radius is already 5. It's not, it would equal 25 in that case.
Yeah.
I see now.
Yeah, and one thing is parametric equations are very pretty and easy. There are no square roots for circles. So it's kind of nice. And same thing with ellipses, by the way. They're very nice, and they're not so nice when it comes to rectangular coordinates, because with circles, if you have a y in terms of x, then you're going to have square roots and messy stuff. But these aren't bad if you don't mind trying too much. Okay, any questions on question 1? These are like, if you watch me do it, they're really easy, but sometimes doing it yourself is not as easy. Sound right? Okay, and maybe it was all easy. That would be wonderful too. Okay, so question 2 also will be really easy if you know what to do. So find the parametric equations of the line that passes through the points 5, -3, and 1, 2, such that at t equals 0, the curve is at 5, -3, and at t is 1, it is at 1, 2. So I like to write it in vector form for a couple reasons. One is it's easier, and the other is it gets you used to vectors, which are really important. I think most of you are in physics anyway, so you're doing vectors, but we're going to be doing vectors from about 3 weeks from now. basically for the rest of your life of doing engineering or whatever you're doing, vectors are really important. So I like to write it this way, even though we officially don't know what one is yet. Hopefully you're okay with me writing a vector form. So x comma y is equal to, and if you remember in the lecture a couple days ago, it's just y equals mx plus b, okay? But not y as in the letter y, really the vector equals m vector times t, not x, plus b. So what we're going to do is we're going to take the slope vector, and to get the slope vector, all you have to do is subtract. So we just take 1, maybe I'll write it out. So 1 minus 5, because that's the x difference, comma 2 minus -3, t, plus, and now the, not y-intercept, but the t-intercept, and that's 5, 3. Any questions on that so far?
What if we didn't show our work on the quiz, but we did it like on a piece of paper? Do we take a picture and email it to you? Or
Okay,
is there like
so I'd rather you practice doing it on the computer, and here's the reason. I have a reason. The quizzes aren't worth many points. I don't know if you realize that. What the quizzes are there for is practice, and especially practice on what the exam is going to look like. And on the exam, you're not allowed to take pictures. Everything's been doing in the box. Oh, I lost the negative. Thanks. There we go. -3. Okay, so you want to practice for the exam, and this is the best way of practicing for the exam. Does that make sense? Okay. And in terms of not showing your work, here's the danger of not showing your work. If you don't show your work and you make a mistake, you get a 0 because there's nothing there. If you show your work, you make a mistake, but it was some minor thing like what I just did, lost the negative sign. I'm going to give you all but like a half a point off or something, but I'll give you almost all the points. Does that make sense?
yeah, it does. Thank you. I'll do that.
Yeah. But you do want to practice typing because again, the exams have typing because, you know, I wish we were back in class and we can just do it on paper, but we can't. COVID will be over soon, I promise. Okay, so now let's just put this together and we can write x of t equal, and hopefully you're okay with me doing 1 minus 5 in my head. That's -4t plus 5. And y of t is equal to, and that's 2 minus -3, which is 5, t minus 3. Any questions on that? Okay. By the way, a quick check of the work. I always like to check. If you plug in 0, what do you get for t? If you plug in 0 for t, what do you get?
5 -3.
Good, and that's what we want. Is that clear? If you plug in 1, we get 1, 2, and that's what we want. So if you could check your work in 2 seconds, it's worth it. Just let you know. If it takes 20 minutes to check your work, it's not worth it since the quiz is only 20 minutes. Okay, so let's go to the third one. So consider parametric equations. X of t is 2 minus t squared, and y of t is equal to t squared. Right, y is a function of x. Okay, so you'll notice that we have t squared in both of these. So what I'm going to do is I'm going to solve for t squared. And I'm going to use kind of like calculator notation. It's a pain in the butt to show you and have the new screen show up and stuff with Zoom. So hopefully you're okay with the little caret thing for powers. So I'm going to take, we know x is equal to 2 minus t squared. So that means that t squared is equal to x 2 minus x. Are you okay that I did that in my head? Added t squared to both sides and subtracted x. So then finally, we plug in 2 minus x for t squared in our y of t. And that one I think I'm going to need to do on the computer because it looks too messy if I do it in typing. So let's go and I have to do it this way. 2 minus x. There we go. So we get y of x equals e to the 2 minus x. And hit insert equation. And there's our answer. Any questions?
Larry, is it supposed to be y of x or just y?
I wrote y of x to be very specific, so it actually tells the story a little better. If you wrote y, you'll get full credit. But for teaching purposes, I wrote y of x to emphasize that y is a function of x, not of t. Does that make sense? But
Yep.
But I wouldn't be so picky to, like take off points if you didn't write the of x. But I think it's easier to read if you see of x, isn't it?
Yeah, it's way more explanatory.
Yeah. So again, I'm a teacher, you're not, so you don't have to worry about those things. Okay. But if you wrote 5 minus x or e to the 5 minus x, yeah, then I'll take off points because that would just be wrong. Any questions on this quiz? Okay, these problems, hopefully you agree, are really easy to watch. There's nothing going on, but again, you have to kind of practice and know how to do each of the steps so that you can make it easy for yourself too. And practice is important. Any questions at all on the whole quiz? Okay, if not, let's go to back to the lecture piece. So we're at Q&A time. And I want to ask you, are there any questions about anything? That could be the homework that's due today. That could be something about the course itself. Could be about the weather today. I don't care. Any questions?
I have a question about the homework. So if we got stuff wrong, I realized after I finished the whole thing that you had to retake it. Is there a way, I know in the math 106, the homework, like if you got one question wrong on the homework, it gives you you get another question, so you still can get the point.
Yeah, we kind of talked about this last time, but maybe I wasn't.
Yeah, because I was like, I don't want to retake the whole thing.
So here's what happened. I copied it, I think, from Bruce's class, because you know how that works. And Bruce made a mistake. It happens. Maybe it was me, but I think it might have been him. But the point is that it didn't work. And then you let me know 2 days ago that it wasn't working. But once someone has started working on it, I can't change it.
Okay, so the future problems will try to change.
Exactly. I went in and changed every one of the assignments for the rest of the quarter. But this assignment, I couldn't change because once someone starts, the system doesn't allow me to change it because someone's already started it. You can't change rules in the middle is the idea. Or let's say I can't change rules in the middle. You can't change rules ever, but I can't change rules in the middle, as in when someone started. And that's why I told everyone, don't start the second assignment because I wanted to get to it.
So is there also a message instructor one after you changed it too? Because I know the first homework assignment did not have like the icon that says message instructor.
Okay, I have to look at that about the options also. Again, I just did a copy.
Yeah, no worries.
Yeah, now you can always email me too.
Okay.
But
I don't see it there right now.
Yeah, so I'll look at the other assignments. That one I think I can change because I think so, even after you've already started it, because I think that one has nothing to do with grades and stuff, but I'll check. Whereas the other one has to do with grades, so I can't change it in the middle. Does that make sense? And again, David Littman wrote the system, so I can't change that. I wrote a lot of the problems, but he wrote the system. So, and he's a great guy, by the way. So yeah, I'll take a look at the message instructor because that makes the email easier. Because if you hit if the message instructor is there, then you don't have to tell me anything about the question you're working on because it gets sent to me. So I'll take a look at that, but after class, I'm not doing it in the middle of the class.
Yeah, that feature would be helpful.
Yeah, and that's typical of classes is that little tweaks like that are going to be needed. It's impossible to get it perfect until it's been tried by you guys. And I'm not you, so I can't test it quite like you can. Because I have like privileges to do anything. You know how that works. Other questions?
Actually, Larry, I have another question about, I remember in first quarter, you gave an offer if you do half of or all the homework assignments with 50%, we could drop our lowest exam grade, or you average the lowest exam grade. Is that still a thing?
Here we only have 2 exams, so there aren't enough exams to do that.
Oh, okay.
So it's
That
different.
works.
Yeah, so it's fewer exams. Okay. The main thing is just do well in the exams. That's the most important thing. And hopefully you will. And I do want to warn you that the last 3 or 4 weeks of the class is the hardest. So be ready for that. For most people, not for everyone, but for most people. That sequences and series, remember summation notation and stuff? A lot of that stuff. So it looks totally different. We could actually do it in either order because you don't need any of this stuff to do that. Other questions?
Larry, I had a homework question for
Sure.
18.
Sure.
I just
If you can read it, then I can type it as you read, if you read slow enough.
let me just click to that screen. It says, I don't know how to say that word, but a bullet is given by x equals velocity cos of theta or beta.
Is it VEL or V or what is it?
VO.
VO?
Yeah.
VO cosine
A
of
T.
theta. Of T. Let's call it T. Make life easier.
And then there's y equals VO sine of
Okay.
theta.
By the way, just to this is not important, but we always say V naught. And
Okay.
it's V naught, and that's because the British got to it, and that's how you say it in British English. So
Okay.
remember Newton, he wasn't from America, so we're stuck with that. Okay, and then y is equal to V naught.
Sine of, what is that? I think that's beta. And then t minus a half gt squared.
Okay, is it beta times parentheses or?
It's sine beta times, or I don't know. I forgot what that meant.
And then what? T minus a half?
T minus
Is that what you said?
a half gt squared. I think it might be easier if you look at it because it's a lot.
Yeah, well, the only way I can do that, I'm gonna stop my share and you're gonna have to share your screen. Can we do that?
Okay, yeah, we can do that.
Yeah, because we can't both share screens together.
Yeah,
So
that
that's
sounds
good.
good.
So give that a shot and then we can talk about it.
Okay.
Okay, good. Much easier to read this way.
Yeah.
Okay. And then V naught is 400, G is 9.8. Hopefully you know G is 9.8 because that's gravity, right?
Yeah.
Okay. And then alpha is pi over 3 radians. Okay. When will the bullet hit the ground? So there's a couple questions. Is that the question you had, the first one?
Yeah, I just wanted to make sure I was doing it right since we only have one shot.
Okay, so if you want to know when the bullet will hit the ground, when it hits the ground, what coordinate do you know?
Would it be?
And you don't have to look at anything, you just have to listen. When it hits the ground, what coordinate do you know?
Would it just be 0?
Which is it? There's a lot of letters here.
T equals 0?
Not T, because T is when you started.
Okay.
What's 0 when it hits the ground?
What's 0?
And that's the key. All right, maybe I'll tell you.
Okay.
So notice that we're in an XY plane.
Yeah.
Y is the up, down, X is the left, right.
Uh-huh.
And the ground is when the up, down is at 0.
So just 0, 0.
When Y is 0.
Oh, okay.
So when Y is 0,
yeah,
you hit the ground. Do you see that?
Yes.
Okay, so not t, not x, but y.
Oh, why? Okay.
So when will it hit the ground means set y to be equal 0.
Okay.
And you get 0 equals v naught sine of alpha t minus 1/2 g t squared.
Oh, okay.
But v naught, alpha, and g are all just numbers.
Mm-hmm.
So this is just y is equal to, I'm just going to call it at minus bt squared.
Okay.
And that's just a quadratic.
Okay.
And in fact, you can factor the t out. And then
Okay.
you don't even have to use a quadratic formula because you do it by factoring. Okay. Does that help in terms of how to do that one?
Yes.
Okay. And then how far from the gun will the bullet hit the ground? So how far from the gun, what variable is that
How from here?
when it hits the ground?
Would that be your x then?
That's the x.
Okay.
So notice in part A, you found your t when it hits the ground, right?
Mm-hmm.
So if you know the t, you could put the t in for the v naught cosine alpha t, and then just use a calculator and put in the numbers.
Okay.
Does
Sounds
that make total sense?
yes.
Yeah.
Thank you.
Remember, this section has no calculus, so don't expect any derivatives or anything.
Yeah, I just wanted to make sure because we only have one shot and I didn't want to miss
Yeah. Yeah. And sorry about that, but from tomorrow on, you'll have more than one shot.
it. Okay. Sounds
Just-
good. Thank you.
Okay. Let me share my screen now. Other questions? Okay, if there's no questions, I think we'll get to calculus since we didn't really do calculus last time. There was no derivatives, no integrals, and no limits. So let's do some calculus. I want to think about the calculus. If we have a parametrically defined curve, what's the first thing you do in calculus?
Find a derivative
Yeah, actually, it's the second thing.
or the slope of a tangent line first.
That's still the second thing. The first thing you do in limits. I know it's been a long time, but I promise you we did limits first. And then we found the derivative. And the derivative or slope of the tangent line is really important. Okay, this is where you got to get a little careful. If a curve is smooth, so there's no like jagged issues or anything like that, does the derivative exist? What do you think? Any thoughts? Okay, if it's continuous and smooth, so it was kind of a trick question because yes, if you are in first quarter calculus, but guess what? We're not in first quarter calculus anymore. So let me give you again the very first curve you ever learned in life. And that was when you were a year old, maybe less than that. Probably a little more than that, actually. And that was circle. Is circle smooth? Will you ever hurt your finger if you touch a circle? Okay, and I'm not saying it's hot or anything, just by, no jagged issues, right? Okay, but it turns out a circle does not have a derivative everywhere. Does not have a slope of a tangent line everywhere. Anyone know why? Can you think about it?
Because there's no corners.
No corners is good, actually. Right? Corners have no derivative. Where does a circle not have a derivative?
The center, because
The center's not on the circle. Center's not on the circle, right? So the circle are the points on the circle. Okay, so I'm going to go to Desmos, and maybe I'll pop in an ellipse just for fun, make it a little harder to to type in, but better for understanding applications and stuff. So the nice thing about ellipses, they're really easy in parametric. So how about 2 cosine of t, comma 3 sine of t. Let's let t go from, how about 0 to 10. Circles are very smooth, aren't they? Right? You're never going to be like suddenly changing directions or anything like that. But is there a derivative, a dy over dx derivative everywhere on this example? And Erez, it looks like you got the right idea. Where's the issue on this example? Anyone see? Actually, top and bottom is no problem. 0 is a great number. No, nothing easier than working with 0. It's actually left and right. So if I look at, say, the right here, can you tell me the slope of the tangent line at that point? What do you think? Okay, the answer is no, right? It's a vertical line. Vertical lines don't have slope. Is that clear to everyone? So I wanted to at least visually show you that there's going to be issues that are unexpected. Because if you look at 2 cosine t and 3 sine t, those have wonderful derivatives, right? Derivative of 2 cosine t is negative 2 sine t. The derivative of 3 sine t is 3 cosine t. There's no problem with them, right? They're as smooth as you can ever get. But at this point right here on the right, there is no slope of a tangent line. So I want to give you a little warning before we proceed that you got to be careful about using what you did first quarter and just doing it by instinct, because instinct will hurt you. Okay, even though this circles and ellipses are as smooth as you can get, does not mean there's a slope of a tangent line. Any questions on that? On the other hand, everywhere else, there is definitely a slope of a tangent line. Okay, so if I grab a point over here, then I can take that, I could look at a tangent line, I can find its slope. Any questions on that? So what we're going to be doing is doing it algebraically. So in other words, instead of just by looking at a picture and visualizing it, because that'll give you an idea of the slope of the tangent line, but not the exact number. We want to be able to get the exact slope of a tangent line. So let's do that. And what we have is we're going to have a theorem. So the theorem is the following, and it's beautiful. That if you have parametric equations, then dy over dx is equal to dy over dt divided by dx over dt. So it's easy. And we can see where the problem was with the ellipse. The idea here is when you have dy over dx, it's a quotient. Quotients have problems if the denominator is 0. And you better all know that by now. So if the denominator is 0, then you're not going to get it. You're not going to get an answer. So if dx over dt is 0, you're in trouble. Okay, there is no slope of the tangent line. There is no dy dx. So if dx and if dy dt and dx dt are both differentiable, okay, they both, I mean, if y and x are both differentiable, and dx dt is not 0, then the derivative dy dx exists. Okay, and that all comes from here. Any questions on the theorem before it's a very simple proof, before I do the simple proof. And I promise you, this is like beautiful. So I can actually do this proof in, the hardest part is the typing. If I said the proof, it would take about 10 seconds. But I got to type it. It takes a little longer. So let's do that. And the key is just write out, just kind of trust me, write dy over dt. And the idea is y is a function of x and x is a function of t, right? Who remembers the chain rule? Hope all of you, because the chain rule is the most important thing that happened in first quarter calculus. So dy over dt by the chain rule is going to be equal to, as soon as I write a fraction, dy over dx divided by dx, I know this is small, I'll make it bigger in a bit, over dt. That's the chain rule, isn't it? And I know it's small, so there we go. Do you all agree that's true? I'm sorry, dy over dt, sorry, dy over dx, not over. dy over dx, see, you should have said it's not true, is dy over dx times dx over dt. That's better. Do you remember the chain rule? Okay. What do I have to do now? Look at our goal. Our goal is the theorem. And the answer is it's very easy. What do I have to do?
Cross out the dx.
I could do that, but if I cross out the dx, then I get dy dt equals dy dt, and I got nothing. That doesn't help at all. Look at my goal. My goal is to say what is dy dx. How do I get dy dx by itself? If I have dy dx times dx dt, basic algebra, how do I get dy dx by itself?
Multiply by reciprocal.
Yeah, or divide by dx dt. And that's it. That's the whole proof. So maybe I'll write it in words. By dx over dt. And we get the theorem. Isn't that a beautiful proof? Because there's nothing to do except the chain rule. And that's it. Okay, so I love those. So simple, easy proofs I'm definitely going to do in class. The brutal ones I say, just trust me. But this one's not brutal. This is simple. Okay, so this always works. So the nice thing is it's not that hard to use. Okay, there's nothing really tough going on. Any questions so far? So now let's do an example. And I promise you, it's not hard. And in fact, I feel that it's so not hard that I could have you try the example first, see if you can do it using the theorem. So let's suppose we want to find the equation of the tangent line to x of t equals t squared plus 2, y of t equals t minus e to the 2t minus 4. And t is equal to -2. I'm going to give you a minute or two. See if you can find the equation of the tangent line, and hint, hint, use the theorem. You got to remember what we did first quarter, and you got to remember the equation of a line, y equals mx plus b. So I'm going to give you a couple minutes. It shouldn't take longer than that. And when you have it, put it in the chat box. It'll look like y equals some number, x plus some number. And you do have to remember your beginning algebra and also your beginning calculus, first quarter calculus. Okay, so it should look like y equals a number times x plus a number. That it needs to be that form. Otherwise, it's not the equation of a tangent line. You know, mx plus b form. not supposed to be that hard. There's a couple little fractions, but nothing too bad. Okay, so we got one try. It's been a while, so maybe I need to do it. Okay, so I promise it isn't that bad. Okay, at least it won't be that bad to watch me do it. But I do think it's good practice to try it yourself. So that's why I gave you a shot. So let's do it. Okay, so first thing, we're going to use the big theorem. And also, we're going to use your memory of calculus, and hopefully you remember some. And that is the slope of the tangent line is the what? In one word. The derivative. Yeah. So we need to find the derivative. We need to find dy dx. Otherwise, why would I have asked this question, right? Okay, so let's find dy dx. So let's do that. I think the easiest is for me to copy it. Okay, so we know that dy dx equals dy dt over dx dt, which is equal to, now we just do it. So dy dt is derivative of t is 1. What rule do I have to use to find the derivative of 2e to the 2t plus 4? Hopefully you remember. Yeah, chain rule. Derivative of 2t plus 4 is 2. E to the 2t plus 4. Any questions on dy dt? dx dt, I'm hoping you can all get that in your sleep. What's the derivative of t squared plus 2?
2t.
2t. Okay, then t is negative 2. So, by the way, I tried to be nice to you. What's 2 times negative 2 plus 4? 0. And e to the 0 is 1. So we're looking at 1 minus 2. That's negative 1. And then over 2 times negative 2, which is negative 4. Let me write it as a nicer fraction. I think it'll be prettier. So negative 1/4 is the same as 1/4. Negative 1 over negative 4 is 1/4. And there's our slope of the tangent line. Any questions on that? Okay, in fact, maybe I'll even write down just so that we've got it. That's b in y equals mx plus b. I'm sorry, that's not p. What am I doing? That's m. Much better. M for slope. Now let's do b. B is not hard at all. Okay, a little bit messy, but not too bad. B is equal to, well, that's just the x and y coordinates, right? I plug in negative 2 for t, and you get negative 2 squared plus 2, which is, shouldn't need a calculator for that. Okay, negative 2 squared is 4. 4 plus 2 is 6. Comma. Okay, and then we're going to plug in negative 2, which we already noted that e to the negative 2 times negative 2 plus 4 is just 1. So just get negative 2 minus 1, which is negative 3. Any questions on the basic arithmetic? Oh, I'm sorry, that's not b. That's let's call that point. So we'll get b in a moment. So then we remember the equation of a line formula. And that is y minus y naught, which is negative 3, equals m, which is 1/4, times x minus 6. And then just working out a little bit of fraction arithmetic stuff, you get y equals 1/4 x. And then we have a y plus 3, need to subtract 3. We have -6/4, which is -2/3. Negative 3/2. So -3/2 minus 3 is -8/2. If I did in my head all right. Any questions on that? So again, a little messy fraction, but otherwise it's not too bad. Okay, so that's an example. It's not that hard to find a derivative, but again, you have to remember everything you learned, the main stuff that you learned in the first quarter calculus class, which is all about derivatives. Okay, so then that was the first thing to do. The second is, if we know how to find a derivative, how do you find a second derivative?
Repeat the process.
What's that?
Repeat the process.
You can repeat the process, or better yet, we have a theorem. It'll be a lot easier with the theorem. So here's the theorem, and it's very simple. And the proof is as simple as what I had just done before. And that is the following. So the second derivative, d squared y over dx squared, is just d over dt of dy dt divided by dx dt. So it's kind of very similar. You take the derivative and then divide by dx dt. And since it's the second derivative, you take the derivative of the derivative. Any questions on that? Okay, and the proof is immediate, because you just got to remember the second derivative is the derivative of the first derivative. Hopefully you remember that. So d squared y over dx squared is equal to dy, there, dy over dx of dy over dx. Oh, sorry, d over dx is what I want to say. Of dy over dx. Do you agree with that? That's just the definition of second derivative. All right, I like to think about this. Instead of dy dx, I want to just give it a name. Let's call it f. Sound good? So that's d over dx of f of x. So it's easier to think of that way. But when you do a first derivative using our last theorem, it's going to be in terms of t, right? Because you have dy over dt over dx over dt, and that'll be in terms of t. So I'm going to write, instead of f of x, I'm going to write f of t, because that's what we're looking at. But guess what? We're done. Because this is what we just did. Okay, so the idea here now is we can just use the chain rule, just like we did before. So we've really already done this. So that's df over dt, d over dt times df over dx. Okay, so let's write that out in fractions. So you write it as a chain rule. So d over dx, or df over dx, is the same thing as df over dt times dt over dx. Any questions on that? And then we just divide like we did before. So we can solve. So what we get, the main thing to note is if we divide, then we end up with a dx over dt on the bottom is the idea. And we get d over dt of dy dx over dx over dt. Okay, it's a lot to say. It's much easier to do than to say. But what's the one thing that's going to be hard about this formula? Anyone know? And when I say hard, I mean not hard conceptually, just messy. Anyone see the messy thing that's going to have to happen with this formula? Here's a hint. It starts with a Q.
Quotient rule?
Yeah, quotient rule. Because if we look at dy over dx, dy over dx is a fraction. It's a quotient. And then this formula says take the derivative of that quotient. And guess what? You got to use the quotient rule. Okay, most of the time. So just a note is that expect the quotient rule to come up when you're taking the second derivative. So let's do an example. So let's see if you can find d squared y over dx squared for x of t equals t minus t squared and y of t equals t minus t cubed. Okay. By the way, could you just solve for t and then not have to worry about all the horrible formulas? Get y in terms of x? Could you do that? What do you think? And then you could just take the second derivative. You don't have to worry about the formula. Okay, the answer is yes, and you would not want to do it because you'd have to solve for t here. To solve for t here, you're going to have to use the quadratic formula. And then you're going to have to plug the quadratic formula into this mess. And it is going to be miserable. And then you're going to take two derivatives. So no, you don't want to do it. Can it be done theoretically? Yes. Do you want to? No. Okay. And just note, sometimes you can't even do it theoretically without what we're going to do at the last part of the quarter. Yeah, make a good decoration for a large building because this has a cube, and the cube there actually is a formula for. That'd be for going the other direction. And no, we don't want to do that. So I want to note that don't go try to solve for y in terms of x when you have anything that's even a little messy because it's going to get brutal. Instead, we use the formula. So as you're used to find the second derivative, you first find the first derivative. So let's do that. So dy over dx is equal to, going to make a fraction, and that's going to be dy over dt, which is 1 minus 2t squared. 3t squared. I'm hoping this is easy for you, taking a derivative of a polynomial. And then over dx over dt, which is 1 minus 2t. And I know this is small, so let me make it bigger. Any questions on that? So far, so clear? I didn't do anything fancy or tricky. Okay, so now that we have that, now what it says, according to the formula, let's go back up to the formula. Maybe I'll even make that really big so that we've really highlighted it. So now it says take d over dt of dy dt. So let's do that next. So you want d over dt of 1 minus 3t squared over 1 minus 2t. What calculus rule do we need to use? The hint is I just talked about it.
The quotient rule.
Use the quotient rule. Quotient rule is real common in these second derivatives, as you can see. And notice that our original question didn't have any divisions. There's no quotient here, right? X of t is t minus t squared. Y of t is t minus t cubed. So quotient rule just appears, and it's just the way it is. Okay, no matter how messy it is, we got to live with it. So let's go ahead and use the quotient rule. Okay, now hopefully you remember the quotient rule. That's important, by the way. And that is you take, low d high minus high d low, square the bottom, and off you go. So low is 1 minus 2t. And then d high is negative 6t. Stop me if there's anything you're not following. And then minus high. High is 1 minus 3t squared. Times then d low. The derivative of 1 minus 2t is negative 2. And then we're supposed to square the bottom. So 1 minus 2t quantity squared. And away you go, or off you go. Are we done?
Can't you simplify more?
No, we don't need to. Are we done though?
Still need to divide by dx dt?
Yeah. And I will let you know the number one mistake people make on exams is to forget to divide by dx dt at the end. And I don't give you a 0, but I can't give you 100% if you forget. So don't forget that in the formula, maybe I'll even take that formula and take that piece. And make it red to like say, hey, remember this. Wait, it may not let me make it red. I don't know if I don't think I can make a piece of a formula red. Nah, sorry. Well, imagine it being red. So don't forget that after taking the derivative of the derivative, you need to divide by dx dt. So, which is not hard. So that just means you're going to have another 1 minus 2t on the bottom. So I'm going to do the following. So d squared y over dx squared is going to be, well, if I divide by another 1 minus 2t, this becomes 1 minus 2t cubed. So it's actually really easy. Now, I know it's been a lot of months. Do you remember my rule about how on an exam, which is what's most important, about how you should, how much simplifying you need to do?
Yeah, none.
Yeah, none. Okay. So you're all saying you need to simplify. No, you don't need to simplify. I'm fine. But what you have to do is all the calculus. Okay, so again, and if you didn't have me first quarter, then this is my rule. On the exams, you must do calculus and you must finish all the calculus steps. But I will never take off points if you didn't simplify, because that's fine. And showing work is important too. Okay, so hopefully, I don't know what Bruce's rule is actually. Funny thing, we've been office mates for 20 years, except for this year because we're at home. But did he make you simplify?
I think it depended. He more of had tests that were open note, open internet, but were super hard. So the problem took up like 2 pages of work.
Yeah, I'm kind of the opposite. Mine are closed notes, closed internet. But I mean, the quiz problem, does that take 2 pages of work when you looked at it?
It took like 3 lines at most.
Exactly. And that's how most of the problems on my test are going to be. So I'm not going to tell you who's better. I'm just going to tell you my style is different than his style. So you do not have to simplify. but you have to understand. If you don't understand, you'll never get this. Does that make sense? And I try to make the problems not too evil in terms of the, the working. Some people have trouble with my true false questions because they're tricky. just give you a warning. But I try to make the problems not 2 pages of work. I try to make the problems a little bit of work. Like this wasn't that much work, was it? Okay, and quotient rule basically, there's no way to avoid the quotient rule for example problems. It like always happens, okay, or just about. So, and you can see why. Any questions at all on this example? Okay, so let's move to the next topic. So we're leaving derivatives, and hopefully you remember after derivatives, what'd you do in calculus?
Riemann sum.
Yeah, or integrals. You could call it Riemann sums, but let's call it integrals because that's nicer. It sounds better, doesn't it? So we're going to do integrals now. And in particular, the geometry of that was area. So here's a big theorem. And it says, if x of t, y of t are a parametrically defined curve above the x-axis, then the area from t equals a to t equals b above the x-axis and below the curve is given by the area is the integral. Let me make this bigger. So the area is equal to the integral from a to b of y of t times x prime of t dt. Any questions on this particular big theorem? Do you think the proof is very hard? What do you think?
I mean, if it's the like limit definition proof, then yeah.
Yeah, then it would be hard, but we're gonna be able to do without. The answer is no. It's actually not gonna be hard at all. So it's a little basic one-step proof and you're done. So I'm gonna do it. One-step proofs I do. Okay. So what I'm gonna do is the following. We know just from from regular calculus, hopefully you still know, that the area is equal to the integral from a, I'm just going to call it a to b for now, and that's going to be y of x dx. Right? Do you remember that from last quarter? I hope so. That was like the most important thing that happened last quarter, is the area is the integral. Are you good with that? All right, well, unfortunately, we don't have y of x. We have functions of t. So what can you do?
Turn the y of t equation into a y of x equation by solving for t using the x equation.
Yeah, all you have to do is realize if we write this in a different way, if we write this using D form, then x prime of t is the same as dx over dt. There's nothing there, right? I hope you all agree. That's just another way. It's basically Newton's versus Leibniz, right? Newton writes it the first way, Leibniz writes it the second way. So dx over dt. Are y'all good with that? Do you recognize this? Okay. And you can write y of x if you want, because you're more used to that. Doesn't matter what letter you call it. Let me do something different for you. What if instead of t, doesn't matter what letter I use, just to give you a hint, let's call it u. What does it look like? This is u substitution. That's all this is. That's it. We're done. This is how u substitution works, right? You let u equals this function of x, and then you've got it. And you always have to do the u substitution. In other words, you have to have that du. Do you remember that? You have to have the derivative of u with respect to x. And that's what we've done. So that's the whole proof. It's u substitution and it's finished. So that's why I like it, because it's beautiful. There's nothing there. But you have to understand all the letters, and you might have not have been thinking about this for a while, just this way. Okay, so the good news is this is easy. And not only that, there's no quotient rule, but now comes a question that you might be able to answer because it's not as long ago. Now we're in integration. What technique might you need commonly to integrate y of t times x prime of t dt? From last quarter. When you have a product of two functions, what do you often have to do? Not always, but often.
Product rule?
Integration by parts.
Integration by parts. There is no product rule for integration, but there is integration by parts. So be ready in case you need integration by parts. The other thing that could happen is something called giving up. You ever had to do that? Because unlike derivatives, you can always take a derivative if it exists, right? Integration is not that way. Until the end of this class, we're going to learn how to take an integral of anything. And I will let you know the tears will flow. So I'm not going there. It's really hard. But integration by parts will often be the way. Sometimes use substitution if you get lucky. But just to note that those are the techniques you may need. Any questions on the big theorem? So now that I've proven it, I'm going to just erase that because I want you to know the main point. And that is the area is the integral of y of t times x prime dt. And that's it. All right, so here's the question for you. Okay, find the area of the ellipse. X of t equals a cosine of t, y of t equals b sine of t. By the way, you might have done this last quarter. I don't know if Bruce did this with you. Did he? Did he do the area of an ellipse? Not in parametric form, but just in general. If he did, it was brutal and painful. Do you remember it? People usually remember pain. Okay, and it used integration with trig substitution. It was horrible. Do you remember that at all? Or maybe it was so painful you have no memory of it. That happens sometimes too. But the good news is, if you write it in parametric form, it's actually not too bad. So let's find the area of the ellipse. Well, it's pretty easy to do. All we do is we integrate. And I need to make it really big. There we go. And the other thing we're going to want to do, there's two things. One, we only know how to find area above the x-axis, but hopefully you all know ellipses are symmetrical. Do you all know that? So ellipses are symmetrical. So what I can do is I can take above and below, just take the above, multiply by 2, and I'll get the full ellipse. Any questions on that? And then, oh, you know what? Yeah, this will work. So we're going to go from 0 to pi, because that'll give you the above part of the ellipse. And then, according to the formula, let's look at the formula again. It says y of t. Y of t is b sine of t. And then it says times x prime of t. The derivative of a cosine t is negative a sine t. So I'm going to pull the negative outside. dt. Anyone lost on this? Any questions? Okay, I'm going to do I'm going to clean this a little bit, actually a lot. And I'm going to do a few things. One, I'm going to pull the a and the b out. So I can write it as a negative 2ab. The other thing I'm going to do is realize I have a sine of t times sine of t, which is sine squared of t. Who remembers the double angle formula, or the half angle formula for the sine squared? So you may not remember it.
Is it cosine squared plus 1?
No, there's 1 minus cosine squared, but that's not going to help us at all, because then we still have cosine squared, which isn't easy either. So again, it's a trig formula. You may or may not remember it, but it is 1 minus, remember the sine squared of t is 1 minus the cosine of 2t. Do you remember that? All over 2. But the over 2 and the 2 and the 2 times 2 cancel. So that's gone. And I get 1 minus cosine of 2t. Any questions on that? Okay, that's easy, I hope, for all of you, is it? Okay, what's the integral of 1? You better all remember that. The integral of 1 is t. T from pi to 0 is just pi. Okay, the integral of cosine is sine, right? But the important thing is that the sine of 0 and the sine of 2 pi are the same numbers. So when you subtract, it goes away and you just get 0. Forgot the equal sign. So you just get AB times pi, or pi AB. There's the pi. And that's the answer. Okay, and notice, by the way, if A equals B, you have a circle, right? Why is that good? So what do you get if A and B are both R?
R squared?
You get pi R squared. You get pi R squared. And pi R squared is the area of a circle. I hope you all know that. So that's important. So we actually just proved that the area of a circle is pi R squared. Isn't that cool? Negative. So there's probably an extra negative here I lost. So let me see. Cosine is sine. X is cosine. Y is sine. And I'll have to go find it. I only have so much time, so I want to make sure. Yeah, it should be positive pi AB. So I think there's an extra minus sign. I just got to find it. So somewhere in there, there's an extra minus, and I got rid of it at the end because I know the answer, because pi R squared, I know, is the area of a circle. Yeah, we did integrate a negative cosine, and that have an extra negative, but I'm not even sure if that's it. So I have to look. Oh, I know what the problem is. The problem is we're going backwards. You're going right to left instead of left to right. And when you go right to left, you get the extra negative. So it's a little tricky, subtle negative sign. Because if you go 0 to pi, you're going in the opposite direction. Whereas if you integrate, so it really should be, so the real issue is that it's pi to 0, not 0 to pi. Or you could write 0 to pi and then drop the negative. So that's where the negative goes away. Any questions on this? So this is a big theorem, actually. We just proved that the area of a circle is pi R squared. I don't know if you've ever seen that proof, that the area of a circle is pi R squared, but it's a biggie, and there it is. Okay, good luck trying to prove it using geometry. Good luck, it's not going to happen. You need calculus and you need this. All right, next one. I think I'm not going to prove this because we only have a few minutes left. But if x of t and y of t are parametrically defined, is a parametrically defined curve, I'll make this a little bigger for you, then the arc length of the curve from t equals a to t equals b is the integral from a to b of the square root of x prime squared plus y prime squared dt. And that comes from the arc length formula that you had last quarter when it was just y and x. And trust me, the proof is easy, but I don't want to spend 5 minutes on it because we don't have 5 minutes. Any questions on this equation? Okay, and do you think this is going to be easy or hard to integrate for most examples?
On the miserable side.
Yeah, and I would say not just on the miserable side, steeply on the miserable side. So let you know, often I'll say, set it up. And that's enough because most of the time you'll not be able to integrate this. Okay, most things are impossible. Okay, you can approximate it, but you can't, most of the time you can't. Square roots of sums of squares are not nice. Okay, even if these things are linear, you're going to have to use inverse trig substitution. And if they're not linear, it's impossible. So I want to note that, we got this beautiful formula, but in the real world, you're going to have to use approximations. So notice on my example, it says set up the integral that gives the arc length. Okay, if it says set up, does that mean you're going to have to use inverse trig substitution when you're done? Any thoughts? Yeah, the answer is absolutely no. So if I give something like that on a test, read the instructions. If it says set up, don't spend time trying to integrate, or you're going to be wasting your time. You're not going to be able to finish the exam. Does that make sense? So this is a setup question. Okay, and I will let you know, you would never be able to do this one. Okay, but you can set it up at least. So it's easy. What I'm going to do, just for fun, is I'm going to copy and paste the formula. Then just put in, and then it'll be really easy. So arc length is the integral from a to b. What's a? Very easy.
One.
1. And what's b?
3.
3. So hopefully you agree that was easy. X prime, is x prime easy here? What's the derivative of the e to the 3t? Yeah, 3e to the 3t. Okay, and how about y prime? What's y prime? What's the derivative of ln of t?
1 of t, 1 over.
1 over t, and then we square, so it's 1 over t squared. Whoops. Let's try it one more time. That's better. By the way, if I asked you to actually solve this integral by hand, what would you do?
Die mad about it.
What's that?
Probably use sub.
You would die. Well, hopefully you wouldn't die. Better is to quit.
You would
Quitting is better than
use
dying.
sub and chain roll first, but then I would probably get stuck.
You would get, not probably. No, this isn't a doable integral. This can be proven to be impossible. So the answer is usually these are impossible. And if you look at our original, parametric equations, they're not so bad. But most of the time, getting the arc length is truly impossible to get the exact arc length. Okay. You can get approximations. You can use a calculator and it'll give you as many decimals, 5 decimals or something, but you're not going to get the exact number, period. Okay. So and that's why just note, read the instructions so that you don't die or don't quit because you can't do this. It's not possible. Okay. And trust me on that one. Okay. And I'm sure you trust me on this particular example. You could try U-subs or any other kind of thing. Nothing's going to work. Okay. And then the very last thing, actually, that was the last thing, is arc length. So we're out of time, which is good because I just finished. So I'm going to stop my share. I'm going to stop the recording.